Hello. On this video, we're going to see how to find the 6 trigonometric functions in the plane, being given one of the ratios and the quadrant. On this particular problem, we're given cosine, and we're told that we are in quadrant number 3. So if we want to think about this as being in the plane and perhaps inside of a circumference, we can sketch a quick circle. And that means that the r that we're looking at here, distance on the circle from the center to any point on the circumference, particularly one in quadrant number 3. We're also told that we're using, this is quadrant number 1, number 2, number 3, and number 4. And we know that cosine of t, it could be cosine of theta, cosine of alpha, is pretty much the same thing. Cosine is equal to x over r. And we have to consider that r is to be positive. In this case, we're told that cosine of t is equal to minus 4 over 5. So the minus 4 is going to be assigned to the x. So we're going to have minus 4 over r, in this case, 5. So that means that x is equal to minus 4 and r is equal to 5. So let's have that right here. So r is equal to 5 and x is equal to minus 4. So we're just missing y, but it makes sense that x is negative since we are in quadrant number 3. So as of now, we know that this is x and this is y, and x is negative. And because we are in quadrant number 3, we expect to have y as negative as well. And how do we find that y value? Well, let's write down what we know. We know that x is equal to minus 4, and we know that r is equal to 5, always positive, and we're missing y. But because this is a circle, and because we have a triangle, or we have a figure that resembles a triangle inside of a circle, so we can use the fact that r squared, or the thing that we used to know as the hypotenuse square, is equal to the x, which would be the plane the part of the adjacent, and y the opposite. So we're going to have x squared plus y squared. We're going to substitute what we know. We know that r is 5, so 5 squared is equal to the minus 4. The entire minus 4 is going to be squared, and y squared. That is 25 is equal to 16, positive 16, plus y squared. Then 25 minus 16, and we're almost there. 25 minus 16 is going to give us 9. So 9 is the value of y squared. Then we are going to find y. Y is equal to plus minus the square root of 9. And that's going to be plus minus 3. So we need to consider both options, but we are already aware of the fact that the third quadrant, y needs to be negative. So always be aware of the quadrant. So that means that our final answer is going to be that y is equal to minus 3. And over here, y is equal to minus 3. And let's write that down. So we have that y is equal to minus 3. And from that moment on, it's just about completing the ratio. So we have that sine is equal to y over r. In this case, y is minus 3 and r is 5. Then we have cosine, which was already given to us as minus 4 over 5. And tangent is y over x, with keeping in mind that x cannot be equal to 0 because it would be undefined. So in this particular case, we're going to have minus 3 over minus 4. And that ends up as 3/4. If you notice, on any quadrant where y is positive, meaning quadrant 1 and 2, sign will be positive because we're expecting any coordinate up here to be positive. So you can always use the signs of x and y in each quadrant to find which of those will be positive and negative. So that means that sine is 3/5, cosine is minus 4/5, and tangent is 3/4. And that would make cosecant minus 5/3, then minus 5/4 as secant, and 4/3 the tangent. And if you notice, it makes sense with this that only tangent and cotangent are going to be positive in quadrant number 3.